Okay, so we need to define linear equations. So basically, first let's review what we saw last time, the term or the terminology, algebraic expression. As I said, it's just a combination of numbers and letters together that makes an algebraic expression. So this is an expression. For this to be an equation, it needs an equal sign. Hence the name equation. So an equation has an equal sign. Expression does not have an equal sign. The expression does not have an equal sign. It's something like this without an equal sign. But once we add an equal sign and something on to the other side of the equation, for example, 3, so we have what we call an equation. Okay, so that's the difference between an equation and expression. Or it could be an inequality if you have, for example, less than here, we have greater than instead of the equal sign. There would be inequality, or it's not an equation, it's the opposite of equation, inequality. These are equalities or equations. Okay, so every equation needs to be solved. First, let's say why we call this a linear equation. Linear, basically because of the power of the variable x, or the unknown x. What is the power of this x?
1.
1. That's right. When you don't set power over a letter or a number, the power by default is 1. That's basically what makes that a linear equation. If the power was 2, it would be a different type of equation, would be second degree or quadratic. But this is what we call linear equation or first degree. We got linear. Either linear or first degree equation. Okay, so it's all about the power. So first degree equations are easier to solve compared to second degree or third degree. We're going to see those later this semester, but today we're only going to see how to solve first degree or linear equations. All right, so let's now see how to solve these equations. So solving linear.
Professor, can I ask a question?
Yes, go ahead.
All right. I just wanted to know, like, if, all right, it says x plus 1 equals 3. So would you minus 1 on both sides to get the variable x?
That's right. That's right. That's what we're going to do in a moment. Yes.
Oh, I'm sorry. I was jumping again. I'm sorry.
That's all right. Yeah. Yeah. If you're ahead of us, that's all right. So this is an equation, basically a simple first degree equation. What this means is a number that we don't know, when added to 1 is 3. What's that number? So we can already know what the number is, but we're going to see what are the actual steps, what's the procedure to actually find that number. So a number plus 1 is 3. We all know that number is 2, but let's see how to actually find it. What you do is we try to isolate the x. We want it by itself. By itself only on one side equals some number, some value, which will be the solution. So for this one here, we want to get rid of this number. Okay, so we don't want we want the x by itself. We don't want the 1. So we're going to isolate the x. In order to do so, we need to cancel the positive 1. How do you cancel the positive 1?
You minus.
Professor, do you, yeah, she said it.
So basically, you can either move it to the other side and change its sign, or you can just do the opposite of it. As we saw last time, the opposite of a number is a positive 1. The opposite of positive 1 is negative 1. And these two, what happens to them?
You cancel them out?
They cancel out, that's right. So we're going to subtract negative 1 here to cancel the positive 1. Do the same thing on the other side. It's an equation. You have to keep it balanced. If you do something on one side, you have to do the exact same thing on the other side. So
question, Professor, you cancel out with that thing, the 1 and the 3?
We're going to cancel these two. So positive 1, negative 1. That's 0. Cancels out. The equal sign. And then the other side. 3. Take away 1.
Cancel it out.
That's right. That's what we said earlier. Okay, a number plus 1 is 3. That number must be 2. And this is the actual way how to find it. So this is a simple one-step equation. Okay, it's not always this simple. it could involve one step or many steps. One step. This is just a one-step equation. As we go, the equation is going to get longer, a little more complex, but we're going to follow all the steps to solve it. Okay, so that's one example. Let's do another one. This time, let's make it something like this. Okay, another first degree equation. Again, what makes it first degree is the power of the x. Power of the x is 1, so that's first degree or linear, as we saw earlier here. So again, the purpose of solving is to get the x by itself, to know the value of it. It's not always as simple as this one, for example, here. So we want to get the x by itself.
Can I do that one, Professor?
I'll walk you through it, okay? Just gonna walk through it so everybody could.
Okay.
Okay, but everyone in the chat in the room, please feel free to engage and say something, ask questions. Okay, everybody in this room. We have Crystal, we have Cyril, Evans, Jeffrey, Lokani, Leilannette, Reader, Shayna. Everyone feel free to engage, please, and ask questions. All right, so again, the purpose of solving is to get the x by itself. If you look over here, the x is not by itself. We have this number, we have this number. So we want to cancel these numbers, 2 and 4, in order to get the x by itself. Once the x is by itself, that's when we say that the equation was solved. All right, so what number do we cancel first?
4.
The negative 4.
The 4.
Yes.
How do you cancel the negative 4?
You add 4 on both sides.
On both sides.
Positive 4 both sides.
Exactly. So we need the opposite of negative 4, which is positive 4. So we're going to do positive 4 here. Positive 4.
It's 12.
These two cancel out. So we have 2x by itself left. The equal sign. 8 plus 4, that's 12. We still don't have
And divided by 2.
That's right. We still don't have the x by itself. We need to cancel the 2 in order to get the x by itself. To cancel the 2, first you got to look at the operation here. What's the operation between 2 and x?
Multiply.
Multiply. What is the opposite of multiplication?
Division.
Division.
Exactly. So this time we're not subtracting 2. Instead we're dividing by 2 because we have a multiplication. 2x means 2 times x. We're going to divide by 2. Divide by 2 on the side. So the 2's cancel out. 2 divided by 2 is 1. 1x, or simply x. You can say 1x or just x. And over here, 12 by 2, that's
6.
6.
okay, and that's the solution we were looking for. Okay, so how many steps did this one take? 2 steps, right? So we can call it a step. Okay, 2-step equation. This one took only 1, but the equation again could be as simple as this, or it could be much more complex than that. Okay, so this is a 2-step equation. So this is what we call the addition property. When we add it to both sides, we call that the addition property. We subtract it from both sides. We call that the subtraction property. Of course, here we did the division property. Sometimes you may need to multiply it. We're going to see that in a moment. Now, let's make a longer. Just when I start recording a lecture, that's when all the helicopters and construction in the neighborhood starts. Always at the same time as when I start the lectures. Thank God it's gone. All right, 3x minus 1, 3 times x minus 1, maybe 12 here. Another one, this time, what's added to this mix?
The parentheses.
The parentheses. So now we're going to try to do the same thing. We're going to try to add, we'll get the x by itself. What do you think we do first to solve this equation?
Multiply the numbers in the parentheses first, because it's like PEMDAS.
That's right.
So
what do we call that property? What do we call that property?
PEMDAS.
PEMDAS, okay. What this specific property or operation here, we saw it last time. What do we call it?
Commutative.
Not the commutative. This is a multiplication or? Say it again?
Distributive?
That's right. We distribute the 3 over the parentheses. Distributing just means multiplying. So 3 times x, that's 3x. 3 times negative 1, that's negative 3. Then we have 12. Once we clear the parentheses, it looks back like this. Okay, so we're just going to follow 2 more steps and we'll have our solution. What do we cancel first again? We're going to add 3, add 3.
15.
These 2 cancel out, so 3x equal 15. The final step is,
Divide.
that's right, you want to get rid of the 3. By the way, if this was a -3, you have to divide by -3. So you want to cancel the number, you divide it by itself. This is a +3, so you divide it by itself. Don't forget to do the same thing on the other side. These 2 cancel out, so x is 15 by 3, which is
5.
5. And that's it, that's the solution. Again, we can easily check. We can plug the solution, for example, here. Let's check, see if it actually works. So to find out whether your solution works, you have to plug it in. You have to plug it into the very first equation. You're going to take the 5, plug it into this equation, and see if it works. This is going to be 3x, which we found out to be 5. It's a proposed solution. It's not confirmed yet that it works. It's a proposed solution. So when we plug it, we actually check the validity of the solution. When we say, is it equal to 12? We're not sure yet, so we cannot assume it's equal. We have to put that question mark until we check and find out. Now, when we simplify this, what do you do first? Think about PEMDAS.
At the starting,
Multiply the numbers in the parentheses.
That's right. Now we have to do
By
inside, not the multiplication. We have to do inside because these are like terms. Now we can combine these. Here we didn't.
Oh, yeah.
Okay, here we didn't have anything to do inside the parentheses. That's why we moved to multiplication, because these are unlike terms, as we saw last time with the algebraic expressions. But with these two, they're like terms because they're both constants or numbers, so we can do the parentheses first.
Professor, can I ask you a question?
Mm-hmm.
I mean, even if you decided like not to do the PEMDAS, would that be all right or no? Would that still mess it up?
The best course of action is to follow PEMDAS. If you don't do PEMDAS, it would look probably longer. It would look a little weird. You may get it wrong, okay? You may want to distribute here, but it's probably better to do the parentheses, okay? Always follow PEMDAS. Even here, we followed PEMDAS, actually. We don't do anything inside, that's why we move to parentheses. So parentheses, exponents, then multiplication. And 12 equals to 12. We still need that question mark here. But do we need the question mark here now?
no.
We don't need it. As you can see, those statements are the same. So we say the solution checks. 5 into the equation checks. If you get something that does make sense, a contradiction, for example, 12 equals 7 or -1, that's when you say not equal to, and you have to recheck. First recheck this, and then backtrack, go back to the equation. But you want to double check your signs here before you go back and check all your steps. Okay, so that's another example. Any questions, anybody? Anybody have a question about this one before we move on to another example? Okay, let's try to make things a little more interesting. Maybe, let's see. All right, do 2x. Why not 2x like this? 3x minus 1 plus 5x. The other side will have something like this. Okay, so this one looks a little bit longer than the other ones, but we're going to try. The concept is the same again. All these equations should be reduced down to just x by itself equals something. So the solving meaning isolating the x, no negative, no number next to it, other than the invisible power 1, the invisible coefficient 1 here. Okay, so now. What do you think we do first in this equation?
Distribute.
That's right. Always, if you see your parentheses, try to clear them. Try to work inside the parentheses if possible. Nothing to add or subtract here. These are not like terms. Then you move on to multiplication. We have a multiplication here. So negative 2 times 3x, that's negative 6x. Negative 2 times negative 1, that's positive 2. Again, when you distribute, you multiply. So you're using the rules of multiplication. Bring this down, 5x. And no parentheses, no like terms to combine. This side stays the same for now. Back to this side. So we cleared the parentheses. What do you do next?
Combine the minus 6x and the positive 5x.
Exactly. So we're going to combine like terms. So we're negative 6 plus 5. What's a negative 6 plus 5?
Minus 1.
That's right. So negative 6 plus 1 will be negative 1x. And positive 2 is by itself, nothing to combine it with. It's going to stay the same, and this side stays the same as well. All right, again, clear the parentheses first, combining it like terms. Do the same thing on the other side if you have parentheses or like terms. Once you do that, now each side is completely simplified, but we have the x on both sides, we have numbers on both sides. Cool. So the purpose again is to get the x on one side only and the numbers or the number, the solution on the other side. What do you think we do at this point now?
Take the x on the right side and put it to the left, minus x.
That's right. So we want our x's to be on one side. So we're going to take this, we're going to move it over next to this similar term. At the same time, we're going to take the positive 2 and move it back to be combined with positive 4. But be careful when you do such moves. When you move something across the equal sign, what happens to it?
The sign changes.
Exactly. So we have an x here or a positive x. Technically, that's a positive x. If you move it over next to this one, so this one turns into a negative x. This one stays the same, negative 1x. But this one here moves over, becomes a negative 1x. Whenever you move something to the other side of the equal sign, you change the sign. So the equal sign is still here. Now we're moving the positive 2 to the other side. What happens to the positive 2 if you move it to the other side?
Becomes minus 2.
Exactly, so negative 2 here. Bring the positive 4, it doesn't change. We didn't move it, still on the same side, the right side. We're just gonna bring it down. Once we move the variables to one side and the numbers to the other side, now we can combine them. What's negative 1 minus 1?
Negative 2.
Exactly, so it's negative. So be careful when you combine like terms, basically using the rules of addition and subtraction. So negative 1 minus 1 is negative 2x. The equal sign here. And what's negative 2? Positive 4 or plus 4?
Positive 2.
Positive. Very good. One last step to isolate this x. What do you do?
Divide by negative 2.
Divide by
Exactly.
negative 2 both
Exactly.
sides.
So it's not a plus 2. We have to divide. We have to cancel this number. Remember, this is a multiplication here. We want to cancel this number, so we're going to divide it by itself. If it's negative 2, we divide by negative 2. It's not add 2 or positive 2. We do that when you have a number by itself. For example, here, you had negative 3 by itself. There's no x here. That's why we did positive 3. Negative 3, the opposite is positive 2. You cancel them out. But if you have 3 next to a variable, you want to divide that 3 by itself. Or if it was a negative 3, you divide it by negative 3 to cancel that 3. So that cancels out. X is basically, don't forget to divide the other side by negative 2 as well. Divided by negative 2, divided by
Negative 1.
That's right. So x will be negative 1. Again, that's the solution. If you plug it into the very first equation, yeah, assuming we didn't make any mistake here, this should check and you shouldn't be a problem. Always check on the side. You don't have to show it, but always check on the side to make sure you got the right solution. Okay, does that make sense to everyone? I know this one's a little longer, but just remember the main stuff.
Kind of.
Let's see. Now let's do another one. Okay, let's do another example similar to this one. Let's say 5x minus 1 plus 10. On the other side, we're going to have all right, so I have another example. So first, again, look at this equation, the equal sign. We have this side, which is an expression. We have this side, which is also an expression. We have a lot going on. We have parentheses on both sides. But remember the main steps. So first, again, we want to work on each side as much as possible and simplify it. Let's add something here just for fun. So we're going to work on each side first. Try to simplify it just like if it was an algebraic expression. So ignore, for example, ignore this right side. We're going to work on this one, then work on this. Let's write the steps as we go. So first, let's say simplify each side. So it doesn't matter how long the equation or how complex it looks, just remember these main steps I'm writing down here. So simplify each side first. Before you start moving things around or subtracting from both sides. Let's work on this one. Ignore this side totally for now. What's the first thing we do again on this side to simplify it?
Distribute.
Distribute. So we're gonna clear the parentheses. So 5x minus 5 plus 10. We'll get back to this side later. Let's do the same thing on this side. Also has parentheses. How do you distribute this right side specifically?
It becomes -3.
That's right. We have this negative in front of the parentheses. Think of it as a -1. And then distribute just like you would do with a 5 or a -5. So -1 times 3, that's -3. The negative times negative.
+4.
That's right, positive 4x. We distributed. Same thing here. Bring down the positive 5. It's not inside. This one is not inside the parentheses, so we are not multiplying it. Back to the first side, simplify each side. So we're going to combine like terms. What combines here? These two, -5 plus 10, which is?
5.
Right, positive.
Positive.
Okay, and on this side, what do you combine?
3 and the 1.
A -3 and 1.
That's right, going to combine these two. And positive 4 stays the same. Just move it to the front. We're not changing any sign, it's still on the same side, okay? We're not moving it across, so it does not change the sign. These two, -3 plus 1 will be?
-2. -2.
Very good. So now we're at this point, we're at this stage. It looks like this. So what do you do? So we need.
You combine, you take the -4x and put it to the left.
That's right. We're going to move this next to this one. And at the same time, move this back here. Much like we did earlier here. But we do that after we simplify each side completely. So what's the second step? Move the x or the variable to one side. And the constants or numbers to the other. Okay, so it turns into 5x minus 4x. And positive 5 moves over, becomes -5, -2. So this is 5x minus 4x, that's 1x, or simply x, equals -5 minus 2 is -7.
-7.
-7.
That's right. If you end up with a number next to the x here, whether, for example, 2 or -3, then you isolate it. So you add another step here. In case you end up with a number like here, we end up with -2x. If we do here, then isolate the x. Divide, subtract, whatever you have to do. Okay, you may have to either add, any of these properties of equations, multiplication or division. But luckily here we have 1x, so you don't have to divide to get the x by itself. 1x is basically just x. Okay, so remember these three main steps. Doesn't matter how complex the equation looks, it always works this way. Work on this, each side first, simplify it. Then once you simplify each side completely, move your x's to one side, then numbers to the other side. After that, you may end up with x by itself. If not, you may need to divide or multiply to isolate the x. Okay, that's basically how you solve first degree equations using basically what we learned last time about algebraic expressions. So basically the equation is made of two expressions. If you look at it, we have an algebraic expression here, we have an equal sign and an algebraic expression on the other side. So everything we learned last time with the real numbers and the properties of algebraic expressions applies, or everything we learn applies to equations as well. So we look at them as two expressions. Okay, everybody, makes sense? Any confusions, questions at this point? Everyone, please let me know. Again, I'm gonna record on this and I'll upload it to Blackboard. You can always go back to it and review it at your own pace, just in case something's not clear at this point. Now we need to, let's see, probably do one more example. Okay, let's look at another example quickly before we disconnect. By the way, when we get disconnected, please come back right away. Click the same link. We're gonna do the second part of the lecture. Also, we will take attendance, okay? We have about 4 minutes. We're gonna do an example. And please rejoin right away using the same link on Blackboard to join the meeting or to rejoin the meeting, and then we'll do the second part, equations with fractions. But for now, let's see if we can do another example. Let's say 7 take away 2, 3x minus 1 equals 4x, maybe minus here, plus 2, and 9. Okay, another complex equation. It doesn't actually, it's not actually that complex. So first again, we're gonna simplify its side. As always, what's the first operation do you do on this side?
Distribute the -2.
That's right. So we're gonna distribute. Do not be tempted. Yes, try to do it. So try to do it inside the parentheses if possible. So do not be tempted by subtracting. It's not 7 take away 2. No, that would be wrong. Do not do 5 here. Follow PEMDAS. P for parentheses, nothing inside. E for exponents, no exponents. And then M for multiplication. Subtraction and addition are the last ones you want to do. So we're going to bring the 7 down, distribute, that's negative 2x. Negative 2 times 3x, that's negative 6x. Positive 2. Same on this side, nothing inside to simplify, so we're going to distribute, that's negative 4x. Okay, positive times a negative. Then positive 8 minus 9. Combine like terms here. So we're going to combine 7 and 2. 7 plus 2, both positive, so that's 9. Bring the negative 6x down. And over here, we're going to combine these two. So here we combined these two. Here we're going to combine these two. Negative 4x minus 1. Then we're going to move this over. Move the 9 to the other side. So negative 6x. Negative 4x turns into positive 4x when you move it to the other side. We're going to move the positive 9, becomes negative 9. And minus 1 stays the same. So here, negative 6 plus 4, that's negative 2x. And equals negative 9 minus 1, that's negative 10. Finally, divide by negative 2. Divide by negative 2. So x is?
+5.
Positive 5, exactly. And the problem is solved. Okay, again, we did all these steps. We're about to get disconnected. Please rejoin again. We're going to do the second part with fractions, and then we will take attendance. And then after that, we go to the discussion board. All right?
Okay.
Okay. Any questions about the last example? Everybody, any questions about the last one?
No.
Okay. Very good. So I'll see you in a few seconds. Please rejoin right away. I'll see you soon.